Hey everybody, I'm MS Farzan, and welcome to this video tutorial on building a multiplayer tabletop game simulator using Vue, Phaser, Node, Express, and Socket.io. Let's get started by looking at the project scope. Our project will feature a Phaser game instance that will allow us to create tokens and cards on screen and move them around on a digital game board. The Phaser instance will be wrapped in a Vue component that will also handle things like multiplayer chat and commands. Together, Phaser and Vue will comprise our front end, which I'll just refer to as the client for the rest of this video, and we'll use Socket.io to communicate with other players and tie together the front and back ends of our app. The back end, referred to from here on as the server, will be a simple Express server that receives Socket.io events from the client and acts accordingly. The whole application will of course run on Node as its runtime. You don't need to be an expert in any of these frameworks to complete this project, but it would be a good idea to have a solid foundation in basic JavaScript and HTML/CSS before trying to tackle the specifics. If you need some help, you can follow my other tutorial on learning JavaScript by making digital tabletop games and web apps. I'll link that at the end of this video, as well as some other helpful links such as the code for this project in the description for this video. You'll also want to make sure that you have Node and Git installed along with your favorite code editor and a command line interface. I also have a tutorial on setting up an integrated development environment that I'll link in the description that you can follow as well. Let's get started and take a look just briefly at each of the frameworks that we're going to use to piece this project together. I have a window open to Phaser.io, which you see is a desktop and mobile HTML5 game framework. I find it really useful for spinning up prototypes for games. The documentation is pretty good, and there are a lot of examples, but there's not a lot of tutorialization around this framework. So if you need some help with it, I would just suggest checking out some of my other tutorials on the topic to get up to speed. We're just going to be using it as the base of our game board where we're moving around cards and tokens, as I mentioned. Vue.js is a progressive JavaScript framework that allows us to create single-page applications using JavaScript for our front end. We're going to use that to house our application, the front-end side of our application in terms of the client, as well as handle chat for us. Express is the fast, unopinionated, minimalist web framework that we're running on Node.js as our runtime. And it's going to spin up a simple web server for us and handle the back-end stuff for us. And the duct tape that's going to piece everything together is Socket.io, which is going to allow us to communicate between clients as well as communicate from the client to the server and vice versa. And of course, all of this is running on Node.js as our runtime. So we'll begin by building our client by installing the Vue CLI. If you go to the Vue command line interface, it's a bunch of tools that allow us to do Vue.js development, like it will watch your files and reload or restart the web server for you so that you don't have to do that. And so I'm going to open my favorite, well, I shouldn't say my favorite, but one of the command line interfaces that I use often. I'm using Visual Studio. You could use whatever you like as your editor. And I'm going to open a command prompt. And I'm going to find my coding directory. And you can find whatever directory you'd like to use. And I usually keep all my JavaScript in my JavaScript folder, and we're just going to create a new folder for our project. Let's call this. We're going to make a directory called Tabletop-project, and we're going to navigate into it. Tabletop-project, and if you don't already have the Vue CLI installed, you can, but you do have Node installed, you'll type in npm install -g at vue/CLI, and I misspelled it, so that's going to be an issue. What that does for us is we're using the Node package manager to install globally the Vue CLI for us to use. That's going to allow us to run a command to scaffold a basic Vue project which, as I mentioned, is going to house the rest of our project. And I like using Vue. You could use, obviously, React or even just use Phaser to handle your chat. I like Vue as a progressive web framework for single-page apps. I just think it's very intuitive and easy to use. And the scaffolding tools provided by the Vue CLI are pretty simple as far as such things go. And they make things a little bit easier on us when we're dealing with chat or handling text, at least I've found. So within this tabletop-project directory, I'm going to type Vue create client to create a Vue project within it that's called client. And you can just press enter here unless you have specifications that you'd like to use in templating that project. And once that's done, I'll go into my code editor and we'll take a look at what it is that we have here in the code editor. This might take longer or shorter depending on your system. The way this is going to work is we're going to spin up a Phaser project within our Vue project, which is actually pretty cool. We'll take a look at what that looks like. Let's move into the client directory, and simultaneously we'll open a folder in Visual Studio. That's in my JavaScript folder and in my tabletop project folder. And just opening this this directory, this is what we have running here. We have a root level tabletop project folder. We have a client folder that was just created for us by the Vue CLI. And that itself has a public folder that just has an index.html, which is the main entry point for the client side of the application. And it has a source folder, which is where all of our JavaScript stuff goes. And let's take a look at that right now. Okay, so we have a main.js, which is the JavaScript entry point for application, which just imports Vue from the Vue package that we have installed, and it mounts our application in at the app ID of index.html, which if we open index.html, we just see a div ID equals app. That's where the app will be mounted. And then the actual app that it's mounting is this very basic Vue template. Template is kind of a misnomer because the way that Vue handles HTML, if you haven't seen a Vue component before, you're allowed to put all of your HTML between these two template tags, and that's followed by any JavaScript that you have between these script tags. And that's followed by this third section where we have style tags, which is where you can insert any CSS that you might have for that particular component of your application. And as we see up here in the HTML, there's a hello world component with a message being passed to it called welcome to your Vue.js app. If we go into the components directory and we look at hello world, we see that it has all of this HTML, JavaScript, and CSS. You can look at this on your own time. We're just going to delete all of this basically, but I just want you to see what the structure of the app is before we run it. If we go back to our command line interface, we can we've moved into the client already. We can write npm run serve to run the app, and if we go into the package.json file, we see that under the the scripts section, or the scripts object within the package.json, we see that when we run serve, it runs this secondary command, the Vue CLI service serve. That just means that we want to serve our project into a web page and have the Vue CLI watch our project for any client-side changes and restart the server so that we can see that displayed on our page. If we navigate now, well, let's look. It tells us in our command line interface that the app is running at the localhost 8080. So we don't actually need all of these different windows. I'll just close them and navigate to 8080. And we see this simple app running that says, welcome to your Vue.js app. That's all of the HTML and CSS that we saw located in the hello world .vue component. And that itself is being called by the app.vue component. Not super important to look at the details of this right now, but we will be using the basic structure of this application for our client. So let's go ahead and break everything. By first, we can delete the hello world.view component. We don't need this logo in here. I don't even really need the assets folder for this project, but you might need it for yours. I'm just kind of obsessed with tidiness, so you don't have to do this if you don't want to. And in the component folder, let's add 2 new files. One of them will be called game.view, and another one will be called chat.view. And in app.view, we have some references to Hello World. So we're going to go ahead and delete that and delete this image that we're not using anymore. Between these div tags, we're going to say div ID equals game. And within that div section, we're going to call the game component that we just created. And then we'll create a little border below that. We'll call that div ID equals border. And then another div ID, which is equal to input. And within that div, it doesn't need to be self-closing, we'll call the chat component and close the div there. And sometimes Visual Studio does this weird thing where you see things aren't really lined up with my indentation, so I'm just going to get an edit, advanced, and format document, and then everything's right with the world now. Great. And that's all we really need to do for our HTML here, just kind of creating some space to to import these components that we're about to write. We no longer have a hello world component, so we're going to import chat from the same directory, chat.view, and we're going to import game from same directory of components, game.view, and view will then export it to the next component up the chain, which is our main.js, which calls app. So we're as we do that, we're going to also export the components of chat and game. Great. Now, if we look at our application here, we don't really see much going on because we've deleted everything. And what we'll do, I'm just going to enter some of my own styling here based on my games. My games are like cyberpunk fantasy games, so I like a nice cyberpunk aesthetic. You can change this as you see fit in terms of the CSS and all the styling. Like all of this is all malleable. It's whatever you want to do. So don't feel like you have to follow this particular style, just something that works for me. I'm going to change the font family to Trebuchet MS. And the text align to left, background color to black, the text color to cyan, nice cyberpunk cyan, and make the display flex. For the game ID, I'm going to make the width 50 of the viewport's width, and the height to take up the entire, or 100 view height. And you can play around with this as you see fit. For the input section, I'm going to make that 50 view width, and the height also 100 view height. So they should take up the entire screen between the two of them. For the border section, I'm just going to say the right border should be 2 pixels, and it should be solid cyan in color. And a quick little note for @media, max dash width. Perhaps for mobile devices, we'll say if the mobile device is less than 1,000 pixels, then we're going to change the app's flex direction to a column, and the game width to 100 view width, and the height to 50 view height. So we're switching that around a little bit to better suit smaller devices. And the input section will change from what it is to 100 view width and 50 view height. Great. So like this isn't really all that special, but we've just created two sections here. One of them is a game section. The other one is like a chat section that we've just split down the middle right now. This will change, but it creates a nice little view architecture for us for what our application is going to look like. You'll probably have to mess with this based on your own application, but it's just something to get you started. So we've actually done everything we need to set up our app.view component, which will house everything else in our client. But before we can actually do anything with it or with our chat.view or game.view, we're going to skip over to the server part of things so that we can create the connective tissue that will make everything else work in our application. So let's look at our server basics. I'm going to move to another command line interface because I need my view command line to keep running. And at the root directory, I'm going to initialize a new project by typing in npm init. And you can just press enter unless you have specific specifications that you want here. And that's just created a package JSON in my root directory, like that. And at this time, I need to install Express and Socket.io. And I'm also going to use a package called NodeDaemon or NodeDaemon, I don't know how you're supposed to say it, to watch our server files for us and reboot them as necessary, just as the Vue CLI is doing for us on the front end. So in this new command line interface, I'm going to say npm install -- save express socket.io and NodeDaemon. And so we want to install those and save them as dependencies to this project. And after it's done that, I'll open that package.json and I'll add I don't really need this test script. I'm going to change the script here, the script object, to have start run NodeDaemon server.js. So when we type npm run start, we want our CLI to run NodeDaemon server.js. So have NodeDaemon run server.js file for us. And as we do that, I'm going to create a new file called server.js. And in it, I'm going to create the basic backend architecture for our application and say constant server equals require express. So we're going to import express. Don't forget your parentheses afterwards. Constant HTTP equals require HTTP dot create server, and we'll pass in server as an argument here. And constant IO equals require socket.io HTTP. So we're importing the three things that we need here, and we're saving socket.io into this variable called IO, or this constant. And in using socket.io, we'll say io.on connection. We want to run a function based on the socket that made the connection. And what that means is that when socket.io receives a new connection, where the server receives a new connection through socket.io, it is going to run this function based on the socket that, or in our case, the client that has now connected to the server. When a client or a new socket connects to the server through socket.io, we want to log to the console a user connected, space, and then plus socket ID, socket.id. So tell us that a user connected and log to the console their socket ID. Now we're going to do a little bit of work here that will seem a little bit obtuse until we come back around to the other side of things. So just hang on with me for a second as we write this code, and we'll come back to it. We're going to say socket on send, comma, function, in parentheses, text, let new text equals, in quotation marks, bracket plus socket.id plus end bracket space plus text, and then io.emit receive, comma, new text. We're just putting this here for now. We'll come back to it in a little bit. This is going to help us handle the parsing of our chat when chat messages are going to be sent, and we'll discuss it in more detail in just a moment. Finally, we'll write socket.onDisconnect. When a socket disconnects from the server, function log to the console a user disconnected, plus socket.id. We want to know when a socket connects or disconnects from the server. Great. So that's what happens when something happens with IO, socket IO. And finally, we're going to write http.listen 3000 function console. Oh, I wrote list and not listen. Console.log server started. And that's what we need to start our server. So we start our server, moving from the bottom up, we start our server at the, this is the port 3000. And when that happens, we just log to the console that the server started. And we're waiting to listen for a connection using socket.io. And when that happens, we want to log to the console that a user connected with their socket ID. And when the client disconnects, also log to the console which socket ID disconnected. Then we have some stuff in between for our chat. Cool. We can test this server by, although it won't do much for us right now, we will create a, well, we already have a command line interface open, don't we? We can spin this up by typing in npm run start, the command that we indicated earlier. And now we see that NoDaemon runs server.js, and we have this message that the server started. So we're testing it. I'm putting heavy air quotes around it by just, we've started the server. We haven't really tested any of its functionality just yet. Okay, so let's, now that we've got this up and running, let's return to the chat component of our client to start building out our chat functionality. So moving back into the client folder, we'll go to chat.view. It's got nothing in it right now. And what we need to do to begin with is actually open yet another command line interface, because our server and our client are running on the other ones, the other two. And we'll navigate to the client directory and type in npm install -- save socket.io -client. When we installed socket.io in the server directory, that was the backend version of socket.io. We need to install the client version of it as well for it to work. Now in chat.view, view, we can enter a bunch of, like I've mentioned before, some template code that you're welcome to follow along. Some of this is essential. I'll let you know which part is and which part you can change. And I'm actually going to start backwards. So we're going to start with the style of this thing, which is probably the most malleable part of this application that you can change based on your own specifications. Some of these things are going to help us with the spacing of everything that's in our application. Others are just cosmetic, and you can change them as you see fit. And it will also depend on the types of devices that you're targeting as well. So we're saying style scoped rather than just style. That means we just want this the style or the CSS of this component to refer to this component alone and nothing else. And we're going to have an ID called container. And for that container, we want to align the text to the left. We want the display to be flex, the flex direction to be column, the left margin to be 1 view width, and the minimum height to be 100 view height. If we have a header, an H1 header, we want the text align, the alignment of the text to be in the center. If there's a hot pink class, we want the color of it to be hot pink. Might not use that at all, but it's always useful for me to have Cyberpunk hot pink and Cyberpunk cyan wherever I'm writing stuff. We're going to have an input ID whose position will be fixed, and the top margin will be 95 view height. The input is going to be the section where people are going to be able to type in the chat that they'd like to appear on screen. And the way this input is going to look, I should say the actual input box that we're going to use, it's going to be a type of submit. We want that, we're writing the chat box essentially right now. We want that to be 25 pixels height. I have a width of 5 view width. The background color of it, we want it to be black, like the background, but we want the text color to be Cyberpunk cyan when we type in text. We'll give it a border of 2 pixels solid cyan and a right margin of 2 view width. That's what our input box is going to look like for our chat. We also want to say input type equals submit :hover. When someone hovers over the submit element, we want the color to be hot pink, and input type equals submit :focus. We want the outline to be none. I see here I'm actually working on a little bit of a incorrect section. What I've skipped here is this is the indeed the submit button when someone wants to submit text, as we'll see. And what we're doing here, we've styled the submit button where we want the height and the width to be of these different values. And when someone hovers over the submit button, we want to change it to hot pink. And importantly, if you run into this issue before, when you click on a button in an HTML button, it has this like like a blue shadow, a blue outline around it. And that's when you're focused on that button. We just want to remove that so it doesn't have this ugly outline that doesn't match the rest of our application. The part that I missed here and that I mentioned, but I mentioned incorrectly, is that actually when we have our input type equals text, that's actually our submit text, our submit chat area, not the submit button. The height of that will be 20 pixels. The width will be 40 view width. The border will be 2 pixels solid cyan. Background color will be black. Text color will be hot pink. And the padding on the left will be 1 EM. So that's what it should look like for our input type text. I'm reading off of my notes, and you can tell that sometimes when I'm typing, my eyes might skip around. So our input type text is going to be of a certain style, and the submit button will also have a certain style. And we make sure that when we hover over the submit button, when someone's ready to chat, it turns hot pink, and that when we click on it, that it doesn't have this weird outline around it. And we just always want to make sure that if we're dealing with other devices, we'll say media max dash width 1000 pixels, that we change things around a bit. We'll say the container, we'll remove the border, the left border on the container, and instead say border dash top 2 pixels solid cyan. And the minimum height should be 50 view height. The input section, we'll say the top margin should be 43 view height. The output section, the right margin should be 10 view width, and our input, our text input, I don't want that, our of type text, we're going to change the width to be 60 view width to better suit, let's say, a tablet or another mobile device. And our input of type submit, our submit button, should have a minimum width of 10 view width. These are just, you know, as I said, placeholders for you to use in my own experimentation of what seems to work well for my browser. You might have to do some edits as necessary, not only for style, but also for functionality. You know, if you have a button text that runs off the page, obviously you'll have to change that. That's all within our style tags of our view component. Let's move our way up the component and add script tags. And in our script tags, let's begin by importing IO from socket.io/client and let's create a new variable, and we'll say let socket equals IO, and IO is going to listen at or communicate at localhost 3000. That's where the server is listening. So when the client connects, it's going to, we want it to connect to the localhost 3000 using socket.io. And we'll say export default. The name of this component is going to be called chat. And we're going to create a data function which returns an object. And data is one way of handling state in Vue, where we can save, let's say, variables that might be that might change, and the web application will depend upon the state of those variables. In our case, we're going to have a text input variable, which starts out being null, and a text output variable, which is an empty array. The text input will be whatever anyone chats, attempts to chat in our application. And the text output will eventually be a number of strings that will be displayed on the page, similar to what you'd see in any chat application, like, I don't know, Slack or Discord or AOL Instant Messenger or whatever. Everything that you see that people have chatted will be the text output, and the text input will be whatever you or another client is trying to type in the chat box. After this data function, we'll have a comma, make sure that we are able to write more things. We'll write a methods object, which is a way of Vue handling custom functions that you might want to run in your application. We're just going to have one function here that's called submit text. That we'll want to run when someone tries to submit text as a new chat. This will be a function that takes an event, and we'll say event prevent the default thing that will happen when you click a submit button, which is kind of like when you're submitting a form. Perhaps it'll reload the page, or it'll send you to an email address or whatever. We just want to prevent whatever that default action would be. But when someone clicks the submit text, a button that runs this submit text function, we want to have the socket emit a send event and send along to the server this.text input. And that's all we need in terms of methods. So when someone clicks a button, which we haven't created yet, we're going to attach a submit text function to that button, and we want the socket to emit a send event when that happens to the server, and send along the line the text input variable, which is right now is set to null, but at some point it will have text in it. We'll return to our server in a moment and see how that's going to work. Finally, we'll add a created function, and created happens when the component is created. Essentially, it's triggered when the component is initialized. In that section, in that function, we're going to say socket on connect, comma, we'll write an arrow function, basically the same way of writing a function with a different scope, different handling of scope. We'll say console.log connected. And this is the web console rather than the server console. And socket.on, when it receives a receive event, it will also receive text. And we'll say this.textOutput.push text, and this.textInput equals null. So when the component is created or initialized, it's going to run this connect function, or connect event, where this is like the client side of the server event when a socket events and we display to the console the socket's ID. We're just going to log to the console to the web console that it has connected. And when the socket receives a receive event, meaning that text has been received from the server, it's going to take that text and it's going to push it or add it to the text output array, and it's going to make sure that the text input returns to null. back to where it was at the beginning of the component's lifecycle. Moving back up the chain here, we're going to add our template tags and add just some brief HTML that's going to display all of the stuff that's happening here. We're going to create a div with the ID container that we've already styled. And at the top, we're going to have a div with the ID of output that we've also already styled. In that div, I'm going to create a header that's called struct. Struct is the programming language in my books and games called Entromancy. So I'm just putting this here as a placeholder title. You could put anything you like or no title at all. It's really up to you. And then we're going to use part of Vue's very cool functionality, and we'll have a p tag, and we'll say v-4 equals, and in parentheses, text comma index in text output, and then colon key equals index, and then double curly braces in between them, we're going to write text. So this is how Vue handles list rendering, particularly when I don't know how many, I'm eventually going to be receiving a bunch of text through chat, and I'm going to be adding it to this text output array. And I don't know how many of those there are going to be. I certainly don't have any of them at runtime. So I'm saying, Vue, I want you to render a list of p tags or p elements for every piece of text that is within the text output array. And Vue generally requires you to have unique elements when you do this, unique keys for the list that you're rendering. So we just use this colon to bind the key to the index of the array, which will be 0, 1, 2, 3, 4, and so on. And then we're able to put JavaScript right in the middle of our p tags by using these double curly braces. So for every piece of text in our text output array, I want you to create a new p tag, a new p element that has that text within it. And that's how we're going to handle our text output, our chat output. Underneath this div, we'll create another one, a div with the ID of input. And here we're going to create a form, which just has two input. The first one is going to be type text input. And we're going to say vModel, I'll explain what that means in just a moment, equals text input. And we'll bind a placeholder to be text input. And below that input, we'll create an input of type submit. Value will be send, and v-on click equals submit text. And that's about the size of our chat application at this time. So what do we do here? The HTML includes input and output sections. The output section has a header, which we have named struct, but you don't have to have that. And we utilize Vue's list rendering to display a p element for each piece of text that we'll have in the text output array, which we don't have at the beginning of the application. The input section has a simple form with Vue, what they call form input bindings, and an event handler to receive input text, and that will in turn store it in our text input variable and trigger the send event through socket.io when the send button is clicked. That's what all of this these two input tags do for us. So our chat, well, let's save it. And we can go into our, well, something that you see is as we're, what's happening in the background is as the view application is saving and reloading the server and reopening the page, it's now attempting to connect to the server, and we see all of these different clients are connecting and one of them disconnected, and these are all the different separate socket IDs that are being displayed on the console, which lets us know that that part of it at least is working. If we look at our page now of our application, we have what's going to be the game window, and we have the chat window, which just has struct at the top. And this is our chat box that we've created, as well as you see when I hover over the send button, the text highlights as hot pink. When I type in this, I can say, "Hello world," and I can click send, and I see that it has now displayed that hello world in my application. And I can say, "Hello struct." And not only are we displaying the socket ID here that has requested that send event, and also the text, but we're also seeing that there's nothing here in the chat box after we press send, because as you'll recall in our code, we've said that we've bound the placeholder to text input, which is changed to null every time we receive a receive event. That's pretty cool. Something else that's cool to test is if we were to open a new browser tab and chat from here. Hi again. And click send. That appears now on our chat will appear across both browsers. So if I say from my original browser, "Hello back," then I see it on both browsers. So what's cool here is that we're not only displaying the user ID or the socket ID, but also the text across both clients. So that's we essentially have created a pretty simple chat server that handles this functionality for us and is going to help us with the rest of our application. Very cool. So let's get on to the actual tabletop simulator part of our app using Phaser. One of the ways to do this is to borrow from a GitHub user. His name is Son of a Beach. I'll link his boilerplate or their boilerplate, I should say, in the description for this video. It's pretty useful, and it's essentially what I'm using here for binding our Vue and our Phaser apps together. You could just use their template from the get-go, their boilerplate, or if you find it easier. I like to create my apps from scratch as much as I can, so we've done some of the hard work to understand how it works before just downloading a template. So let's go. Before we actually create the Phaser part of it, let's go into the game component of our Vue app and add the following code. If we needed, we're going from the bottom to the top again. If we needed style, we could just have style scope. We're not going to use any style for this. In the script section, we're going to just say export default. Name will be game. It's the name of the game. And then in our data function, we're going to return 3 variables. Downloaded, whether or not the game client has been downloaded, we'll say it starts out as false. The game instance will be null. And the container ID, we're going to call it game-container. This is all just to prep our application for receiving a new game instance from Phaser. Add a comma at the end of that. we'll say async mounted when the this component is mounted. We'll create a constant called game, and we'll await the import of @/game/game. The directory, we're looking for a game directory that has a game file for us. And when that happens, we'll say this.downloaded is equal to true. This dot money sign next tick, and then we'll create an arrow function. This dot game instance equals game.launch this dot container ID. Comma. And then when it's destroyed, this dot game instance dot destroy false. Okay, so this is kind of a, I don't want to say a workaround, but it's a shortcut to be able to run a Phaser instance within our View app. We're basically using the async technology of Node to allow us to wait for the game to load and run a launch command that we haven't written yet, so that the game runs in the container ID ID of this View application. So in between the template tags, we'll just create a space for our game to run. We'll say div, and we'll bind the ID to container dash ID. And we'll use View's conditional logic to say vif downloaded. So if the game is downloaded, if the game has been downloaded, we want this, we want to show this particular element, this div, with the ID of container ID. And this shouldn't be container dash ID. It should just be container ID with a capital I. And then div class equals placeholder v else. So if this downloaded should be a comma here. If this downloaded variable is true, then we should be displaying the container ID, which is going to contain our game. Otherwise, display this placeholder div, which is just going to have text that says downloading. You could have a placeholder image or a GIF or however you want to handle it here. But that's this is going to be the basic component that we're using to house our game instance. Check out Son of a Beach's View and Phaser boilerplate if you'd like to know more about how this works. I'll link it in the description, as well as obviously the GitHub code for this entire project if you need to refer to it. So now let's actually create our game instance. We'll go into our, well, we need a, do we have an empty? Yes, we do have a command line interface that's not running anything. So in this client directory, we'll write npm install --save phaser. And this will save phaser as a dependency in our client folder. And Phaser will handle all the rendering of our game objects like tokens and cards, while also making them interactive with drag and drop functionality. So within this, within our client folder, within source, but outside of components, let's create a new folder called game. And in that folder, let's create a subfolder called scenes. So we have this components folder, and at the same level we have a game folder that has a scenes folder within it. And within the game folder, let's create a file called game.js. I want that within the game folder and not the scenes folder. Oh, it seems that it's done that correctly. And within the scenes folder, let's create one called gamescene.js. These are going to be our two main phaser files, just like that. So if you haven't used Phaser at all, it's a pretty simple setup. There is if you were to only use Phaser and not have to have it working with Vue, you could use the official, or I guess semi-official Webpack template that you can search for that will scaffold a basic Phaser app for you. Because we're not doing that here, we have to build it ourselves, but it's pretty straightforward. We're just going to, in the game.js file, we're going to import Phaser from Phaser, and we're going to import game scene from the directory scenes/game scene we just created, and it's currently empty. And we're going to create a function launch. This is also, the way we're doing this is also borrowed from Son of a Beach's template. I think it's I'm not even certain if there's a better way of doing this. It just seems to be an elegant way of handling it. And we're going to use function launch. Remember, we referred to that in our game component, our Vue component, and we passed into it a container ID. Function launch container ID return a new phaser.game parentheses brackets, and in this object we'll put any config that we have. The type is going to be a phaser.auto. The parent of this game is going to be the container ID. We're only going to have one scene. We'll declare that within this array. That's going to be game scene. But if we had other scenes, we could do that as well. Comma. And then in terms of scale, we want it to fit the area that it's being rendered in. So we'll say mode phaser.scale.fit. Width should be 100% in quotation marks, and height should also be 100%. And then after this launch function, we're going to say export default launch, and then export, and then in curly brackets launch. I'm actually not quite sure why one has to do that in this instance, and I've tried playing around with this, but it seems to work for Son of a Beach, and it's worked in my application. So you might have to look that up and figure out why this kind of non-normative syntax is required in this case. So that's it in terms of our setup for our Phaser game. If we go into the game scene, the main functionality of our simulator will be run here. And here we also have to import Phaser from Phaser, and we need to import IO from socket.io-client as we did in our chat. And we're going to use Phaser classes here, or JavaScript classes, to export a default class game scene, which will extend phaser.scene. And in our constructor for our JavaScript class, we're going to refer to the super and say that the key here should be game scene. I want to let it know that the this is the we're extending the phaser.scene, and this one is called game scene, and that's all we really have to do here. Now, Phaser ordinarily still within the exporting our default class, but below the constructor. Phaser normally has a preload, a create, and an update function. The preload is if you need to literally preload any assets like sprites or that kind of thing. The update function is run once every frame if you have something that requires that, like let's say you're running a 2D platform. We don't really need to use them at all, but I'll just write them here in case that you need them for your game. Preload and update. All of our work is going to go between these actually in the create function that is run when the game scene is created. And here we're going to create a new variable called this.socket is equal to IO, which is going to listen at HTTP localhost 3000. And we're using the this syntax because as Phaser is going to be instantiating or creating, well, our application in general is going to be creating these new instances of these classes within our application. We want to make sure that we're referencing each scene within the scope of its creation. So if we just say let socket instead of this.socket, our application might not actually know which socket we're referring to. So we're saying this very socket that this very socket connection within this scene that has been loaded in this application. And we're going to say this.socket.on, and here's where it's going to get a little funky. In our application, the way that we're going to handle the creation of new game objects, so just thinking through a couple of things that I might need in a board game application. I might need cards to be displayed on screen that I can move about. I might need tokens that I can display on screen and move about on a game board. We're just going to create very basic functionality in that regard. We're going to make an ability for people to create a card or a token and move them around on the screen. And we could do that by having a button that we create within Phaser that you click that button and it creates a new token or a new card based on certain specifications. The way that we're going to do that in this tutorial is actually to run a command through the chat, just to make things a little bit more interesting and exciting, and also for our own learning process. It's relatively easy to create a little bit of text in Phaser, and when you click on it, something happens. So we're going to bind our server, our chat application, and our game scene together using socket.io, partially for the learning and partially because I just think it's cool. So we're going to say when the socket receives, this client receives a event called struct create. Remember, struct is the name of the programming language in my novels and my games, Entromancy. It's also going to expect a width and height parameter, and we'll use an arrow function. And within that function, we'll say let token be equal to this.add.rectangle. And we see, at least with Visual Studio, I get this autocomplete that says it's expecting two numbers, a width, and a height, and the two numbers are the x and y coordinates. So let's say we'll want them to be at 300 by 300 pixels. And the width and the height of the rectangle should be equal to the width and the height parameters. And then we need a color. So here we're going to have a nice cyberpunk color of 0x00FFFF. And we'll chain a couple commands. We'll just chain .set interactive. We want to set that rectangle to be interactive. And then below that, we'll say this.input.set draggable, the token that we just created. So we set it as interactive, and then we tell the input of the scene, of the Phaser scene, we set it draggable. And then we also have to say what happens when something is draggable. Well, we'll say this.input.onDrag, comma, and in parentheses, we'll say pointer, game object, drag X, drag Y, and then arrow function, game object dot X should be equal to drag X, and game object dot Y should be equal to drag Y. It's the basic way of having some sort of drag and drop functionality in an application with Phaser. You can see that on the Phaser examples on phaser.io. But when you set something as draggable, you also have to indicate what should be the logic that should ensue when something's being dragged. So we're saying when something's happening, we're using the input system in Phaser to say that when a drag is happening, we want the game object that's being dragged to follow the X and Y coordinates of the mouse pointer. That's how that functionality works. All we have to do here, if we saved everything and went back into our web page, we see that there are some issues here that we haven't resolved. One of them is that our game folder doesn't seem to be referenced correctly. And what it shows is it says that it's not able to find that in the source/components folder. That's a bit weird to me because the pathing should be correct to go to the root level of our directory. We can change that pretty easily by just going into our game.view and changing the path here. Instead of trying to import something from we can just say ... and then now it rebuilds and everything is running correctly. So yeah, not sure why that didn't work for us, but that's okay. We found a quick and easy solution to it. Cool. So what's next? We have to go back into our server, and as I promised way earlier in the video, we're going to talk about this specific function here that we've created here to see how the chat actually works, and then we'll add the functionality for displaying stuff on screen. So when we had in our chat component this send function, we said that when somebody clicks on the send button after they've written text into it, when they click on that, it should run the submit text function or submit text method. That submit text method emits an event using socket.io called send, and it should send along the line the text input variable, which is no longer null. It should have text within it. That is, we've bound that to the text input variable here using Vue's vmodel binding. And so the server is going to receive the send event or emission, and it's also going to receive text, which is our text input. It's going to create new text, and in that new text, it's going to interpolate the socket ID in between these brackets just for a better visualization, and it's going to add that text. And after it's created that new text variable, the server is going to emit to all clients that they have a receive event, and it's going to send along the chain that new text. So if we go back to the client in the chat, when we receive a receive event, we'll take the text that comes along with it, we'll push it into the text output array, and we'll return the text input to null. And that's how the server side and client side aspect of the socket.io event works. We're going to add a new event here. Well, I should say we're just going to add kind of a basic parser that when we receive text from this send event, we're going to parse through that text very basically and see if we receive any commands. So under the new text declaration, but above the receive emission, we're going to say if text equals struct card, then do something. If text equals struct token, do something else. So if somebody writes the words struct card, our server should do something. If somebody writes the words struct token, they should do something else. And so if they write struct card, let's say io.emit struct create, comma 130, 180. And if they write struct token, we'll do io.emit struct create, and we'll also add the arguments 100, 100. Let's think about this. If somebody writes the words struct card or struct token, we're going to emit the event struct create, which we referenced in our game scene here, that we say when we receive a struct create event through socket.io, we're expecting a width and height parameters, and we want to use those width and height parameters to create our rectangle. So here in our server, if someone says struct card, we should send in the arguments of 130 and 180 for the width and height, which is kind of like, it's going to look like a card in terms of the width and height. But if they say struct token, we'll pass in the 100 and 100 arguments, which will be a square, kind of like a token. When we save this, we see that our server now acts as a simple parser when it receives a send event from a client. When we save everything, make sure the server is running. We'll open up a couple of tabs, which we already have open here. And let's just do a little chat. We'll say, hello world. And we say that we see this has created a new socket ID for us. We see that in both tabs. In the second tab, I'll say, hello back. Send it. And I see that in both tabs. Now if I say struct token, I get a token on screen that's on both screens, and I can drag it around. If I say struct card, I get a card on screen that is displayed on both screens, and that's also draggable. And maybe I want another card. Well, that's going to display right on top of everything, but they're all draggable. And I can say struct token, and I get another one that's also draggable around the screen. All right. So when I run these commands, again, I could have a little button here that I create within Phaser, but this is kind of more fun and also interesting if you want to have functionality. Like let's say you have a dice roller and you want dice to roll on the screen. Well, you don't necessarily want to do the text input in your Phaser game instance. You might want that to happen in your from your chat, and that's how you could get that to work. What's not happening here, for example, is when I drag something on this screen, I don't see it move on this screen. That requires another socket event to be used when there is other forms of inputs like drag input on the screen. I have another video tutorial about how to create a multiplayer card game using Phaser, socket.io, Express, and Node. You can check that out as well if you want to build out the functionality, the multiplayer functionality of your game. But by following this tutorial, you should now have a working multiplayer tabletop game simulator with chat, token creation, and drag and drop functionality. I'd say, there's a lot of ways that you could build on this app. For example, you could enhance the styling and add a scroll bar to the chat, or you could allow players to use custom usernames and log into specific chat instances by using socket.io's rooms functionality. I'll link some information in the description so that you can follow that along as you like. There are, of course, a lot of different things you could do by improving the board game functionality by, let's say, using a for loop to deal multiple cards and tokens at once. Or you could use the phaser examples to add your own features, like sprites if you needed them. I highly recommend following along with my How to Build a Multiplayer Card Game with Phaser Express and Socket.io, for example, for some inspiration. But do as you see fit. And we also talked about if you wanted to use things other than chat commands, you could certainly do that. You could handle the functionality all within Phaser. But I really do like using View for chat because it just handles text better, in my opinion. If you're thinking about deploying this app to the web, you certainly will have to add some different configuration to it than what we've done here. You can do that simply by following a couple of my articles, which will I'll also add in the description of this video. And there's a video that I have on learning how to deploy a full stack web app with Heroku. You'll still need to do additional configuration with Socket.io, but I have full confidence that you can do that. So yeah, good luck. Best of luck with this. I hope this video has been helpful for you in creating your own multiplayer digital board game app. If it has been, please be sure to like it and subscribe to my channel for more. I'd love also your help in spreading the word about my own books and games. You can check them out by going to nightpathpub.com/entromancy or just entromancy.com. And we'll see you again soon.